So the big thing that you got to watch for here, again, is common denominators. If everything's common denominator, guess what? You just have to add them. So I'm looking at this thing right now, and I see an x minus 3, x minus 1, and an x minus 3, x minus 1. Order doesn't matter, right? They're both multiplication. It's like saying 2 times 3 is 6, 3 times 2 is 6. Order does not matter when you're multiplying. Now, here's the important thing. That one is not in factored form. So let's factor this, because if it's not common denominators at this point, uh-oh, you're in trouble. Well, guess what? There you go, minus 3 and minus 1. They are, in fact, x minus 3, x minus 1. Everything is common. Look, x minus 3, x minus 1, x minus 3, x minus 1, x minus 3, x minus 1. They're all common. So guess what you can do? This is the best part. You could just put a line all the way across here, because all you're going to do is end up adding all the numerators. But here's the big thing. This is where I catch people again. Don't forget, that was subtraction, which means you have to distribute to both of those. So that becomes minus 10x plus 2. Got it? All right, so don't forget about this guy. That's really, really important. Now, so all we got to do now is combine like terms. Tell you right off the bat, okay, that's going to equal to, guess what? X minus 1, x minus 3, right there. Maybe we should put the non-permissible values now that we're factored, right? Well, this becomes easy. X cannot equal to 3 and 1. There you go. You can get them from any one of the three. This one, or this one. Doesn't matter. Okay, so that's cool. We got that out of the way. Now, let's start combining. If you combine, look, 2x squared. Is there any other x squared up there? No. So you got 2x squared. Okay, let's go to the next one. Let's go to x. You got x, 2x, and minus 10x. So if you look at this, you've got x plus 2x. That's going to give you 3x. Minus 10x is going to give you minus 7x. Perfect. And the last one to look at, you got a 3 and you got a 2. That gives you positive 5. Now, this looks like it's done, right? Wrong. Read this. It says, watch your factoring. Even when you think the problem is done, you may still need to cancel factors. What does that mean then? What that means then is you have to look to see if your answer is not factorable. And in this case, the answer could desperately be factorable. Okay. So let's factor that numerator. The numerator is 2x squared minus 7x plus 5. This is a PSA2. Okay, so this becomes 10 and minus 7. So again, minus 2 and minus 5 work because minus 2 plus minus 5 work. So you can't give an answer because it is a PSA2. You have to decompose it. So there's 2x squared minus 2x minus 5x plus 5. All right, group it. Right? Take a 2x out, leaving you an x minus 1. Take a minus 5 out, leaving you an x minus 1, leaving you with a 2x minus 5 and an x minus 1. Check this out. This numerator now becomes 2x minus 5, which you just figured out, and an x minus 1 over the denominator that we had, x minus 1, x minus 3, and lo and behold, look at that. Oh, look at that. The x minus 1s cancel out. So your actual answer, and let me just clean this up a little bit because we don't need a lot of this stuff in there. Your actual answer, oops, works out to be, oh my goodness, there we go, okay, works out to be 2x minus 5, what's left here, over x minus 3. Look at that. There's your final answer. How pretty is that? Wow. So again, stay calm, find your NPVs, combine like terms, watch out for this wonderful thing that allows us to, of course, distribute the negative and change all the signs, factor at the end, just in case, cancel whatever's left, and this ain't so bad. This really ain't so bad.